Welcome to my SAP Agile Data Preparation vlog. In this, I will show you an IoT sensor information data flow from its origin via the SAP Cloud Platform and the SAP Cloud Connector, via the SAP Data Provisioning Agent, finally into HANA and the SAP Agile Data Preparation client, where it will be augmented with local data. Let's start from the origin. In this, I send temperature information from a Raspberry Pi every minute via a cron job. The same information is sent into a Kafka channel, but that is the topic of another vlog. This information then arrives in the SAP Cloud Platform, specifically in the SAP IoT Message Management Service API. What does this look like? Here is the Message Management Service cockpit, where I could, for example, configure where my IoT sensor information is being stored. And in this case, it's not being stored in a traditional IoT table, but in a HANA database in schema C4PA. So this is here HANA database and the schema C4PA. We'll have a look into this. Here's my schema, and here's the table with the structure of a device ID, a timestamp, and the temperature information. And I can preview the content. It is 170,000 entries, but since we are talking HANA, this is really quick. Next, this information is displayed again in the SAP Cloud Platform, but in the SAP Cloud Portal in a component called Smart Business Service to see whether my temperature information is in a range that I've been defined. And this is what it looks like. I have a Smart Business tile here, and it shows me that the temperature information had been going up in the last hour a little bit into an orange level, but then dropped to green level again. From here, my temperature information travels through the SAP Cloud Connector and a so-called service channel. Let's look into this. Here's my SAP Cloud Connector with 3 SAP Cloud platforms configured, but only one connected. And it is this connection that has the service channel configured. It is an on-premise to cloud configuration. And here I see I have a connection to my C4PA database where I have configured my temperature information to be stored in. So the SAP Cloud Connector works as a proxy towards my Cloud HANA database. From there, the information goes into the SAP Data Provisioning Agent. And that is the configuration of the Data Provisioning Agent. It is connected to my HANA system, and it has a file adapter configured, and it also has a HANA adapter configured here. From there, we reach the target on-premise HANA system. Here, first we have the Smart Data Integration component. Let's look into this. So we have the cockpit here, and we see a tile for the agent monitoring. And if I look into this, I see my agent registered, it is connected, and it has 2 adapters, the adapters we have seen before, file adapter and HANA adapter. As we also see, SAP Agile Data Preparation builds on the HANA rules framework, SAP Semantic Services, and then the SAP Agile Data Preparation component itself. So let's have a quick look into this. So these are the deployments into my HANA system. I deployed the data provisioning, as we have seen, the Enterprise Semantic Services, and then the ADP. I upgraded the ADP and deployed the HANA rules framework. So with this, we have finally arrived at the SAP Agile Data Preparation. Let's look into this. This is the SAP Agile Data Preparation cockpit, and I create a new project for this vlog. I call it vlog. And since we are augmenting IoT sensor information with local data, that's what I put into the description. And I create it. The next thing I have to do is to create a data source. Where does the data come from? I click on data source, and on remote connections, that's where the connections through the data provisioning agents come from. I got two connections, a file adapter for the local data. We have seen the file adapter and the HANA adapter towards the SAP Cloud Platform. So I click on this and I see the information in my SAP Cloud Platform. I'm interested in my C4PA schema. And here I see my IoT table as we have seen before. I see my columns and I import all the records. Remember, these are 170,000 records. So it takes a minute to import, but since we are talking HANA to HANA, despite connecting to the cloud, this is pretty fast. All right. So let's get a bit of an insight into this. What are we talking about in terms of data? Let's sort it. So the first data item was from 11th of April 2011, 9:08 a.m. and then every minute a new data set arrives. If I sort the other way around, it is just 9:08 in the now here in England, and that's when the last data set arrived. And I will show you later how to augment this data because while we are recording this vlog, more time will pass, more information will come in, more temperature information, and I'll update this later to reflect this change. Now we have the device ID, but we are interested in a rough area where this device is located. So I have a file prepared that matches this device ID to a postcode. It's not exact, but it is good for our analytics. So I add this data source to my project. I browse data sources again, remote connections. This time it's a file connection and it's the device's file. Since it's a file, Agile Data Preparation adds a couple of technical columns. I don't need those. I just need the device and the location, and I import this. All right. Now I have to combine the two tables, which is really easy. Combine worksheets. I merge the two worksheets. Agile Data Preparation recognizes that the device column or the G device column is existing in both the IoT table and the location file with 100% match, so there are no orphaned records. So I can just combine the two worksheets. I give it a new name. I call it temperature. Temperature by location, because with that we know where the sensor is and where the temperature information comes from. And here we are. I have the location of my sensor now together with my temperature information. Next, I want to do some analytics with it. So I'm not so much interested in what the temperature is every minute. I'm more interested in what is the average temperature at any given time of the day, in any given hour of the day. So first I have to convert my timestamp into an hour information. And I do this by adding a formula column. The formula in this case is called hour. I choose the hour formula and I apply it to the timestamp. And I call it time. Okay. And with that, I have the hours of the day of the respective timestamp. That's great. So I can aggregate my temperature information by the hour of the day, and I do this by aggregate data. So we want the location because we want to know where we are. And then we would like the temperature, not the sum of the temperature, that doesn't make sense, but the average, and the average by time and every hour. So we see the preview here already. By hour of the day, we got the average temperature. I will save this as a new worksheet. And this is now temperature by time. And I create my worksheet. Great, that's some good insight. But now I'm interested in the reverse. What temperature is most likely to occur at a certain point in time? Perhaps then I could gear an automatic heating system so that the temperature doesn't drop below a certain level, or whatever information I'm interested in. So for this, I'm going to round the temperature information because I couldn't work with those fractions. I add a formula column again. This time it's not the hour formula, it's the round formula. And I round the temperature to a standard format. I don't need to specify this necessarily. And I call this temperature. Okay. So now I got the temperature and the time that rounded temperature occurred. So now I could aggregate again and see, what is the most likely time for a certain temperature. So I aggregate the data. I still want to know where I am. And then the time, but not the sum, that doesn't make sense, but the average time a certain temperature arises, not a function. And here we are. It's the preview, but we already see the lowest temperature is very likely to occur in the early hours of the day, which makes sense because it is colder outside. We have winter, temperature goes down. So if we didn't want to drop, for example, below 31 degrees, we could steer a heating element to increase the temperature. The higher temperatures are over the day. It's not so conclusive. So we would have to dig deeper into this. But at least we know, lower temperatures at the early hours of the day. I save this as a worksheet again. It is time by temperature. And create my worksheet. And with this, I would like to conclude my vlog. I hope this was interesting to you. The full data flow of IoT sensor information from its origin into SAP Agile Data Preparation and then being augmented with local information. Thank you for your